In this video, we're going to talk about how to solve problems involving the Newton Raphson method. And we are going to also look at how to tabulate values that we get from our analysis during the Newton Raphson method. So to start off, there is a very crucial formula you need to know to solve any problem in the Newton Raphson method. So this formula is pretty explanatory. You have an x term, and then the term after the x term is what you're looking for. That's the next step in the iteration. And then you have your function, and then you have the derivative of your function. So let's say we have a problem. So first of all, if we had solved problems on NR method, I prefer to write out the formula first. So I'd say x of n plus 1, which is the next term after the first guess, is equal to x of n minus f of x divided by f prime of x. So from here on out, we need to identify what term is what term from our question. So we know our f of x term to be equal to, so from here we know that our f prime of x. So f prime of x means that we have to differentiate this function. Okay, so differentiating this function, if we have to differentiate x cubed, it becomes 3x squared. Minus, if we had to differentiate 3x, this 3x squared, my mistake, 3x squared. So if we had to differentiate 3x squared, it becomes 6x. If we had to differentiate 5x, it becomes plus 5. And then if I had to differentiate minus 4, it becomes 0. So this is our derivative term for our function. So we can quickly analyze this by saying so this is equal to minus 0.136. So for the f prime of x value, for our first x value, this is equal to so this is equal to 2.48. Sorry, this is a bit scattered here. So if you take all these values side by side and write them here, you have our f of x value is equal to minus 0.136, and then we have our f prime of x value to be equal to 2.48. We have our x n value, that's our first guess value, to be equal to 1.4. Okay, so let's clean up the space here. So cleaning up the space and using our Newton Raphson method formula, we have x of 2. The first term is x of 1. So x of 2 is equal to, let's say this x of 1 is 1.4. 1.4 minus, open bracket, minus 0.136 divided by f prime of x is 2.48. So x2 becomes equal to 1.4 minus, can times minus, so this is plus 0.136 divided by 2.48. So the x of 2 becomes equal to 1.455. So you can continue this method until you start getting constant values in 4 decimal places or 3 decimal places. But in my case, I'm going to be using 3 decimal places. So instead of me doing this again and again, I'm going to do it in a tabular form. So I'm going to be saying, for my table, I'm going to be saying my nth value, okay, and then my x of n value, and then my f of xn value, and then my f prime of xn value, and then of course my xn plus 1 value. So for my first step, I have my n to be 1, and I had my xn to be my first guess, which is 1.4. And I have my f of xn to be minus 0.136. Then I had my f prime of xn to be 2.48. And then I had my xn plus 1 to be 1.455. So next up, I can just use this formula and the corresponding values of xn. So my next term will be 2 here, and then this will be 1.455. So if you use your calculator, remember f of xn is equal to x cubed minus 3x squared plus 5x minus 4. And then f prime of xn is equal to 3x squared minus 6x plus 5. So if you use your calculator here with these values, your next value of f of xn should be 4 times 0.2 times 10 raised to the power minus 3. And then if you use your value for f prime of xn using this formula, okay, so plugging 1.455 into this equation, you get 2.621. Using the Newton Raphson formula, you should get 1.453. Okay, so it's basically the same iteration again and again until you start getting consistent values. For my third iteration, I'm using 1.453 here. So if you pause the video and try to do the same thing again, you should get minus 1.04 times 10 raised to the power 3. And then here you should get 2.626. Then here you should get 1.453. So that's the basic idea. If you notice, the terms have become consistent here. So for the second iteration and the third iteration, my x of n plus 1 values are now consistent. So I'm going to stop the iteration here because further iteration will still give me 1.453 to 3 decimal places. So I'm going to stop my iteration here. If you liked this video, leave a thumbs up, share with your friends, and subscribe to the channel. It helps. Thanks for watching.